If you walk outside tonight and look up at the constellation Orion, you will see a brilliant reddish star marking the hunter's shoulder. That star is called Betelgeuse. It is about 500 light-years away, which means the light entering your eyes right now left that star around the year 1525. When that light began its journey, the Aztec Empire still ruled Mexico. Leonardo da Vinci was still alive. The Protestant Reformation had just begun. And here is what will haunt you. Betelgeuse might not exist anymore. It could have exploded 100 years ago, 200 years ago, and we would have no way of knowing. The light from that explosion has not reached us yet. What you see when you look at Betelgeuse is not what Betelgeuse looks like now. It is what Betelgeuse looked like 5 centuries ago. When you look at the night sky, you are not seeing the present, you are seeing the past. And some of the stars you see tonight may already be dead. To understand why we see dead stars, we must first understand something so fundamental that we rarely stop to think about it. Light is not instantaneous. Light travels at 299,792 kilometers per second. That is roughly 1 billion kilometers per hour. It is the fastest thing in the universe. Nothing can travel faster. Einstein proved this, and every experiment since has confirmed it. At this speed, light from the sun takes about 8 minutes and 20 seconds to reach Earth. When you feel sunlight on your face, you are feeling warmth that left the sun over 8 minutes ago. If the sun suddenly vanished right now, we would not know for 8 minutes. We would continue to see it shining, feel its heat, orbit around a star that was already gone. 8 minutes is barely noticeable. But the sun is our nearest star, just 150 million kilometers away. The next nearest star is over 4 light-years distant. That means the light from Proxima Centauri that arrives tonight left that star over 4 years ago. If Proxima Centauri exploded right now, astronomers in the year 2029 would be the first to see it. And as we look further into space, the delays grow longer, dramatically longer. Astronomers do not measure cosmic distances in kilometers. The numbers would be absurd, trillions upon trillions, beyond comprehension. Instead, they use a unit called the light year. The distance light travels in 1 year. 1 light year is approximately 9.46 trillion kilometers. Let that sink in, 9 trillion kilometers, and that is only how far light travels in a single year. This unit is elegant because it combines distance and time. When we say a star is 100 light-years away, we are also saying that we see it as it was 100 years ago. The distance tells us the delay. Space and time become inseparable. Most of the stars you can see with your naked eye are within a few hundred to a few thousand light-years. The brilliant star Deneb in the constellation Cygnus is roughly 2,000 light-years away. The light you see from Deneb tonight left that star around the year 25 CE, when the Roman Empire was at its height and Jesus of Nazareth had recently lived. But there is a star even further that you can sometimes see without a telescope. Rho Cassiopeiae, a yellow hypergiant, sits about 8,000 light-years from Earth. When you look at Rho Cassiopeiae, you are seeing light that left that star around 6,000 BCE, before the pyramids were built, before writing was invented, when humans were just beginning to settle in the first cities. And that is just what we can see with our eyes alone. Every photograph of space is a photograph of the past. When the Hubble Space Telescope captured its famous deep field image in 1995, it pointed at a seemingly empty patch of sky and collected light for 10 consecutive days. What emerged was one of the most profound images in human history. Over 3,000 galaxies, each containing billions of stars, all in a region of sky you could cover with a grain of sand held at arm's length. Some of those galaxies are so distant that their light traveled for over 10 billion years to reach Hubble's mirrors. We see them not as they are today, but as they were when the universe itself was young, before our sun existed, before our galaxy took its current form, before the atoms in your body were forged in ancient stars. And with the James Webb Space Telescope, we have pushed even further back. In 2022, Webb detected galaxies that formed just 330 million years after the Big Bang. The universe is 13.8 billion years old. These galaxies show us the cosmos when it was just 2% of its current age, cosmic infants, and were captured in ancient light that has been traveling toward us almost since the beginning of time. When you look at these images, you are not merely seeing distant objects. You are looking through a window into the deep past of the universe itself. For most of human history, people assumed light was instantaneous. When you light a candle, the room illuminates immediately. When lightning strikes, the flash seems to reach your eyes at the exact moment it occurs. But in 1676, a Danish astronomer named Ole Rømer made a remarkable discovery while studying Jupiter's moons. Rømer was timing the eclipses of Io, Jupiter's closest large moon. As Io passes behind Jupiter, it disappears from view, and Rømer was measuring exactly when this happened. He expected the eclipses to occur at perfectly regular intervals, but they did not. When Earth was moving toward Jupiter in its orbit, the eclipses seemed to occur slightly early. When Earth was moving away from Jupiter, they occurred slightly late. The difference was about 22 minutes over the course of 6 months. Rømer realized what this meant. Light from Jupiter's moons took time to reach Earth, and that time changed depending on how far away we were. When Earth was closer to Jupiter, the light had less distance to travel. When we were further, it took longer. From this observation, Rømer calculated that light took about 22 minutes to cross the diameter of Earth's orbit. Using modern values, this gives a speed remarkably close to the true value. For the first time in history, humanity knew that light was not instantaneous. It was a messenger that took time to deliver its news. So can we actually see stars that no longer exist? The honest answer is probably yes, but we cannot be certain which ones. Most of the stars visible to the naked eye are within a few thousand light years of Earth. Stars live for millions or billions of years, so statistically, most of the stars you see tonight are still shining. The odds that any particular star died in the last few thousand years are low, but not zero. Massive stars, the brilliant supergiants like Betelgeuse, Rigel, and Deneb, live fast and die young. A star like Betelgeuse has burned through most of its fuel in just 10 million years. It is now swollen, unstable, and nearing the end of its life. Astronomers estimate it will explode as a supernova sometime in the next 100,000 years. That is an eye blink in cosmic terms. And since Betelgeuse is 500 light years away, if it exploded in the year 1500, we would not see it until the year 2000. In fact, Betelgeuse did something strange in late 2019. It suddenly dimmed by more than a factor of 2, dropping from one of the 10 brightest stars in the sky to outside the top 20. For a few months, astronomers genuinely wondered if this was the beginning of the end. It was not. The dimming was caused by a massive eruption of gas and dust partially blocking our view. But the incident reminded us that when Betelgeuse does finally die, we will not get advance warning. The first sign will be the supernova light itself, arriving centuries after the explosion actually occurred. Humanity has witnessed stars dying. On July 4th, 1054 CE, Chinese astronomers recorded a guest star that appeared in the constellation Taurus. It was so bright it could be seen in broad daylight for 23 days. It shone nearly as brilliantly as the full moon, then slowly faded over the following 2 years. What they saw was a supernova, the explosive death of a massive star approximately 6,500 light years away. The explosion had actually occurred around 5400 BCE, when the first cities were rising in Mesopotamia. The light simply took that long to reach Earth. Today, we call the remnant of that explosion the Crab Nebula. It is a 6 light-year wide cloud of gas and debris, still expanding at over 1,000 kilometers per second. At its heart sits a neutron star, the collapsed core of the original star, spinning 30 times per second and blasting radiation across the cosmos. The Chinese astronomers in 1054 did not know what they were seeing. They could not have imagined that the brilliant point of light was actually a cosmic explosion that had happened millennia before their ancestors learned to write. But we know. And every time we look at the Crab Nebula through a telescope, we are watching the aftermath of a star that died before recorded history began. The Andromeda Galaxy is the most distant object you can see with your naked eye. On a clear, dark night, away from city lights, it appears as a faint smudge in the constellation that bears its name. But that smudge is actually a spiral galaxy containing roughly 1 trillion stars, more than twice as many as our own Milky Way. And it is 2.5 million light-years away. When you look at Andromeda, you are seeing light that began its journey when our ancestors were Homo habilis, just beginning to use stone tools on the African savanna. The human species did not yet exist. The light you see tonight has been traveling across the void for longer than humanity has walked the earth. Now consider, in the time that light has been traveling, stars in Andromeda have been born and have died. Entire generations of stellar evolution have occurred. Some of the stars you see in that faint smudge may have exploded millions of years ago, their light from the explosion not yet reaching us. The Andromeda you see is not the Andromeda that exists. And it is a ghost image, a portrait frozen 2.5 million years out of date. And here is the strangest part. Andromeda is moving toward us at over 300 kilometers per second. In about 4.5 billion years, it will collide and merge with the Milky Way. But if intelligent beings in Andromeda are looking at us right now, they see Earth as it was before human civilization, before agriculture, before we learned to speak. They cannot know that we exist. The light carrying that information has not reached them yet. Here is a thought experiment that reveals how profound this delay truly is. Imagine an alien civilization on a planet orbiting a star 65 million light-years away. If they have a telescope powerful enough to see Earth in detail, what would they observe right now? They would see the age of dinosaurs. The light from Earth that is reaching them now left our planet 65 million years ago, around the time of the asteroid impact that ended the Cretaceous period. They would see Tyrannosaurus rex hunting prey, pterosaurs soaring through prehistoric skies, the great extinction unfolding. They would have no idea that mammals would rise, that primates would evolve, that a species called humans would one day build cities and rockets, and wonder if they were alone in the universe. From their perspective, Earth is still a world of giant reptiles, and any message they sent to us, traveling at the speed of light, would take another 65 million years to arrive. By the time we received it, they might be gone, and we might be unrecognizable. This is the isolation that the speed of light imposes. We are all islands in time, separated not just by distance, but by the ages it takes for information to cross the void. The universe adds another layer of strangeness to this picture. Space itself is expanding. Every second, the distance between distant galaxies grows, not because they are moving through space, but because space itself is stretching. And for the most distant objects, this expansion is accelerating. There are galaxies so far away that the space between us is expanding faster than light can travel across it. Their light will never reach us, no matter how long we wait. They exist beyond what astronomers call the cosmological horizon, forever cut off from our observable universe. And that horizon is receding. Galaxies that we can see today will eventually cross it and vanish from view, their light unable to keep pace with the expanding void. The light from the most distant galaxies Webb has observed, those from 300 million years after the Big Bang, has been traveling for over 13 billion years. But because the universe has been expanding all that time, those galaxies are now over 30 billion light-years away. The distance has stretched while the light was in transit. We see them as they were, but they are no longer where we see them. They may no longer exist at all. The early universe was a violent, chaotic place where galaxies collided and merged constantly. Those ancient galaxies have been transformed, absorbed, scattered across billions of years of cosmic evolution. So what does this all mean? It means the night sky is not a window. It is a museum. When you look up at the stars, you are not seeing what exists. You are seeing what existed. A collection of moments preserved in light, each one from a different time in cosmic history. The star 8 light years away shows you 8 years ago. The one 500 light years away shows you 5 centuries ago. The galaxy 2 million light years away shows you a moment before humans evolved. And here is what makes this not tragic, but magnificent. This delay is also why we can study the history of the universe at all. If light were instantaneous, we could only see the present. Every galaxy would show us only its current state. We would have no way to study how galaxies form, how stars evolve, how the universe has changed over billions of years. But because light takes time, the universe displays its entire history simultaneously. Nearby galaxies show us the recent past, and distant galaxies show us billions of years ago. The cosmic microwave background shows us the universe when it was just 380,000 years old, light that has been traveling for almost the entire age of the cosmos. We are archaeologists of light, reading the story of the universe in photons that have crossed unimaginable distances to reach our eyes and our telescopes. Every observation is a message from the past. Tonight, when the sky grows dark, go outside and look up. Find Orion if it is visible. Find Betelgeuse on his shoulder, glowing red and ancient. Know that the light touching your eyes left that star before Columbus crossed the Atlantic. Know that Betelgeuse might already be gone, a shell of expanding gas hurtling through space where a star once burned. Look further. Find the Andromeda Galaxy, that faint smudge in the autumn sky. Know that you are seeing an entire universe of stars as they appeared when your ancestors were not yet human. And remember, every star you see is a time traveler. The photons entering your eyes have journeyed across years, centuries, millennia. They carry with them the state of stars as they once were, messages written in light and sealed for ages before they were delivered to you. The night sky is full of ghosts, not in any frightening sense, but in the profound sense that we see not the present, but the echoes of the past. Some of those stars are still there, burning fiercely. Some may have changed beyond recognition, and some, perhaps, have already died. But their light lives on, and as long as we look up and wonder, as long as we point our telescopes into the darkness and ask what is out there, their stories are not finished.